The goal for today's investigation is for you to be able to use equations to solve problems involving percent increase and decrease. And so I'm going to work through two problems here. The first one I'm going to actually start by using a table, and then on the second one we'll go straight into using an equation. And the reason I'll start with using a table is that sometimes it's helpful to sort of see how those equations get created. And the other reason I like using this table initially is I'm going to sort of talk you through a quick reminder of how to find percentages of things by building a percentage table. So in this situation, we've got money in a savings account increases by about 6% each year. And so remember, we're going to use our percent increase, which will be 100% plus this amount. And then it wants to know how much will be in the account after 1 year if the initial amount is $100, $50, $200, or $125, and X dollars. And so let's just start by, maybe we'll write this as percent. I'm going to build a little table. Percent and decimal. And we'll start by looking at, we'll do all of these eventually. So I'll put in a space for $100 for this first one, $50. They also want to know about $200 and $125 and X. Okay. So when we think about percentage, the way I can write this first one here, if it's $100 as a percent, well, I'm simply going to write that as 100%, right? As a decimal, we would write 100% as 1.00. And so 100% of $100, well, that's simply going to be $100. Now, if I want to think about, okay, I need to get up to 6%. Sometimes it's useful to then think about this in terms of 10% or 1%. And so if I were to think about 10% of something, as a decimal, I might write that as 0.1. And remember, when we're going from decimals and percentages, we're simply like multiplying and dividing. And so I can think, okay, I need to get $100. I need 10% of that. I'm just going to divide by 10, which is what I did over here. And so that would be $10. And this 10% isn't really helpful in this particular problem, but if I'd been asked to find like 36% of something, having that 10% might be a useful thing to have in there. And so now if I want to think, well, what's 1% of $100? I could, again, rewrite that as a decimal as 0.01 because all I did there was divide by 100. And 1 is 1% of $100. So the reason that is helpful is that now if I want to think about, okay, I need 6%, this percent, 6% right there, well, that's simply going to be taking 6 times my 1% value, right? So in this case, it would be 1, so I would get $6. I could also write 6% as 0.06. And so I like this strategy because it allows me to think, okay, if I need some crazy amount of percentage, 37%, for example, that's hard for my brain to think about. But if I know 10% of something and I know 1% of something, then I can simply multiply them together. And so really for this one, this was going to be, I was going to add in $6 for that particular one. But what I want really is 106%. So I would write that as 1.06. Oops, no, that's the decimal version. So that would be 106%, which as a decimal would be 1.06. And so now to figure out, okay, how much total money that is, I'm simply going to take my 100% value plus my 6% value. So that in this case, it's going to be 100 plus 6 or $106. So I like using these tables as a way to sort of build it out and to provide sort of a scaffold for myself. And it was nice that we started with $100 on this one so we could see it sort of straightforward. It's a little bit harder as I get into some of these different numbers, but I can use that same strategy. So for $50, well, 100% of $50, that's simply 50. 10% of $50, I'm simply going to divide by 10. That's going to be 5. 1% of $50, I need to divide twice, so that's going to be 0.5. And so now for my 6%, remember I'm going to take 6 times whatever number was here, so I'm going to say 6 times 0.5. Well, that's the same as 6 times a half, which is $3. And so now to get my 106%, I need to take my $100 or my 100% value plus my 6% value. And so I'm going to add 50 plus 3 gets me $53. So this 200 column, I have two strategies I can do. I can simply look at, 200 is twice the amount of this. and so I can sort of double it, but I can also use that same strategy that I've been doing so far, and I like using this because it kind of builds that habit in my brain. So if I think about 100% of $200, well, that's going to be $200. 10%, I'm simply dividing by 10, so it's going to be 20. 1%, I'm dividing one more time, so that's 2. So if I want 6%, I'm going to multiply 6 times 2, gets me $12. And now I can add, for my 106%, I can add my initial 100% value plus my 6% value, gets me $212. So again, this strategy works well for all kinds of crazy numbers, just by simply dividing by 10 each time to get our 100%, 10%, 1% values, and then multiplying to get your respective like 37% or 23% or whatever you're trying to get to. So 100% of $125 is 125. 10% of that, I'm simply going to divide by 10, is 12.5. 1%, now I'm going to divide one more time, is 1.25. And so now I can take 6 times 1.25. So that's going to be 6 plus 7, 750 is the total there. If I wasn't sure, I could use a calculator or do it off on the side. And now for my 100%, I'm going to add, what am I going to do? I'm going to do 125, because that's my 100% value, plus my 6% value, which was 750. And so that's your 125 plus 7 is 132.50. So again, I like this strategy because it allows you to look at percentages that are kind of unique just by using a table, and I didn't have to really do too much complicated math. And then it sets me up well to figure out this X situation. So in terms of like over here, this would be whatever 100 times X was, right? Like whatever my X is, it's going to be, I guess a better way of saying that would just be, it would be X. If I think about 10% of X, that's going to be 0.1X. If I think about 1%, that's 0.01X. 6% would be 0.06X. And so our 100% would be 1.06X. The reason this is helpful is if I'm actually creating an equation, I'm going to need to know this. Essentially what I have done in each of this table as I was working through, if I went back through with a calculator and I took 1.06 times this original number, I would get this number down here. So 1.06 times 200 gets me 212. 1.06 times 50 gets me 53. And so this equation, 1.06x equals like our new number, works really, really well. But it does require that maybe like this is a little bit more complicated in terms of using my mental math skills. So maybe I need a calculator. If I'm doing the STAR test and I'm not allowed to use a calculator, I'm like, yeah. This is why having this table is a useful strategy. Is because you can build out like 10% and 1%, and then just think of the percentage you're trying to get to as a multiple of 10 and 1%. So for example, in this problem down here, now I have a value of a car decreasing by about 15% in the first year. So it's decreasing, so I know my number needs to be less than 1, because remember we're going to do 100% minus 15%. So 100% minus 15% gives me 85%. So I can do the same table, but I can also think about, well, let's convert this into decimals, right? So this is 1.00 minus 0.15 equals 0.85. And so we think now that we know that we're decreasing, we can take this number, and just like we did before where we had that 1.06 times our original value, well now if we're trying to find, $1,000, $5,000, $5,020, X dollars, I simply can take 0.85 times whatever the dollars is, we'll get our new value. And so like this one, I can take 0.85 and I'm going to multiply it times 1,000, not 100, 1,000. And I can do the same thing for 0.85 times 5,000. I could take 0.85 times $5,020. And this makes sense that if it's decreasing, that this number would be less than 1, right? When we multiply by a decimal that is less than 1, that value will decrease. And so 0.85 times 1,000, that's going to be 850. What am I doing next? Is 0.85 times 5,000. I'm going to use my tool here of my calculator. That is fine for you to do that kind of thing. 0.85 times 5,000 is 4,250. That's a cheap deal on a car. And then 0.85 times 5,020. Nope. 5,020 is $4,267. So big takeaways from this lesson. You can use a percentage table to think about finding 10% and 1% to help you either establish your percent increase or percent decrease in terms of multiples of this 10% and 1%. And simply you are moving your decimal place one place or two places for that 10% or that 1%. And then the equations you will create, if it's an increase, the number will always be greater than 1. This number, this multiplier, greater than 1, is increase. And if it's less than 1, no, it's less than 1 is what I'm trying to write. Less than 1 equals decrease. And so your basic equation you would get every time is some number times x will get you that new number. And if that number is greater than 1, it's going to be an increase. If the number is less than 1, it's a decrease. We can also go the other way, right? If I had this equation here, 0.85 times some number, and then I was given, let's say this number down here, 4,267, and they said, well, hey, what's the cost, the original price of the cost? I can use my inverse operations to solve for this x. And so since this is 0.85 times x, well, to get rid of that multiplication problem, I can divide both sides by 0.85, and then I would use my calculator and figure out, oh, sure enough, it's 5,020. So that's why I like using equations, is that you can, once you know that sort of multiplying factor, this is a proportional relationship, right? That's why we use that y equals kx strategy, is that it allows us to then solve these percentage problems by using inverse operations.